Welcome guys, let's solve with code 1019 next greater node in linked list. You are given the head of a linked list with n nodes. For each node in the list, find the value of the next greater node. That is, for each node, find the value of the first node that is next to it and has a strictly larger value than it. Return an integer array answer where the i's value of the i's answer is gonna be the next greater node of the i's node, right? So if the i's node does not have any next greater node, set the answer to zero. For let's take the first example. So as you can see in this node, so for this node, for example, for two, the next greater element is gonna be with value, right? So it's gonna be five for the first node. So what about node with value one? It's gonna be five also, right? Because the next element for one is to the right of it is gonna be five. And what is the next greater element that's greater than five? We don't have any, right? So it's gonna be zero here. So let's take the next example. So on the next example, we have this node, right? We have this linked list, right? So what is the next great element for this two, right? It's gonna be this seven, right? So we have seven here. What is the next great element for seven? We don't have, right? So it's gonna be zero. What is the next great element for 4? It's gonna be 5, right? So it's gonna be 5. And what is the next great element for 3? It's gonna be 5. And what is the next great element for this 5? It's gonna be 0, right? So we don't have any great element for this node, right? So the answer is gonna be this one. So as you can see, we have the same answer, right? So, how do we solve this problem? How do we come up with a solution to this problem, right? So, to solve this problem, one thing we can do is we can use let's say we add two let's say we have add two in a stack, right? So we add two here, and since let's say the stack is empty and we add two here, right? And we will we will we want to know, like, is one the next great element for two? No, right? So we will add one to our stack, and we will ask, like, is five the next great element for this node? Yes, it is, right? So what we are going to do is we have to know, like, the position of this node, right? So in this position, let's say we have an answer array, right? Let's say initially all of them were zero, right? Let's say we have zero and we have three nodes, right? So we have zero, right? So at index one, what we're going to do is we have to update its value with the one which is gonna pop this value, right? So because five is gonna be the next great element for one, right? Then we remove this from the stack and we ask again, is five the next great element for two? Yes, it is, right? So we are going to update this value to five, right? Then once have done this, we add 5 to our stack, and now the loop is gonna we don't have any elements, right? So we just return this array, right? So I'm going to use the same way for, let's take one more example. Let's take the first one, the second one, right? And for the second one, let's say we add two to, since our stack is empty, we add two to our we add two to the stack, and we move to this position, right? So we ask ourselves, is seven the next great element for two? Yes, it is, right? So initially we used to have we have how many nodes we have? We have five nodes, right? They say all of initially this was zero initially, right? They say we have five nodes and assume this kind of circle, and we have five nodes. So so at index zero, we're gonna update this to zero, right? I mean seven, right? Then we have popped two from this one, right? And we add seven to our stack, and we will iterate to the end, right? But there is no one that's gonna pop this from the stack, right? So its value is not going to change, right? And at this position, because 7 has no any, then we will move to, yeah, we add to 7 to the stack, and we will to move to the 4, right? And we ask, is 4 the next greater element? No, right? We add 4 to the stack, and we move to this position. Is 3 the next great element first? First step 4 is no, it's not, right? We'll move to this position, and we will ask, is 5 the next great element first 3? Yes, it is, right? So we're gonna update for this position, we're gonna update it to 5, right? It's gonna be 5. 0 is gonna be changed to 5, and we will remove 3 to this position, and we will ask, is 5 the next great element? Yes, it is, right? And we will remove 4 from this position, from the stack, and we will add it to, we will change the value 0 to 5. And is 7 the next great is 5 the next great element for 7? No, right? So the so we will add 5 to this position, and our iteration is gonna end, right? So the answer is gonna be this one. So the time complex is gonna be off in for this, and the space complex is gonna be off in because we are using a stack, right? So let's see, let's go to the implementation. So first we're gonna have a stack. We have an empty stack, and let's say we have an answer array. Then it was initially 0. Then we will start. Our current is gonna start from the head, and we iterate to while the current is not while the current is not none. Then while the stack, and if it is the top of the stack. So we need to have an index also, right? So let's say the top of the stack is at the negative one, at index negative one, and let's say we have a value. Yeah, if its value is less than, I mean, yeah, if this value is less than the current dot val, then what we're going to do is, let's say we have a node val, and let's say we know the index, right? The position of the position. We need to know the position from when we move to from the right to the left, right? So to track that kind of thing, let's say we have index, and let's say stack dot pop, right? And what we're going to do is, let's say we have an answer array. The answer at this index is gonna be current dot next. I mean current dot val, right? We will update it, right? What we are going to do is, if I mean, we're gonna add to the stack. What we are going to add is to the stack is just then the current node dot val, and the length of the how many elements so far I have from when I move to from right to left, how many elements so far I have added to the stack, right? The answer. I mean, how many elements, where am I from the position? I mean, for example, if initially when I was here, the my answer array is gonna be 0, right? So we will add I mean, the index of 2 is gonna be 0, right? Then the length of the answer array is gonna be this one. Whenever I add to the stack in number and a value, that means it tells me where am I in the stack, in where am I in the linked list, right? It tells me the position. So what I do is just in the answer array, just append 0, right, to track the position. So once I have done this, what I'm going to do is just return. What I'm going to return is just the answer array, right? Okay. So so this is going to be, the time complex is going to be off in, as I mentioned earlier, and the space complex is going to be off in, right? Both of them are off in. So let's see if this works. Okay, we have one thing we should check, right? Time daily is gonna be the case because we didn't just move the head, right? I mean the current pointer. We have to move it to the end, right? Yeah, as you can see, pass for test cases, and let's see if it works for all of the given test cases. So as you can see, pass for all of them. Okay, guys, if you like this video, please subscribe. It's gonna help me a lot, and please share if someone out there wants to learn about data structure and algorithm.